Flores, Indonesia. The morning of August 15th, 2026. A lush tropical coastline sitting squarely on the Pacific Ring of Fire, asleep just before dawn. At 5:58 a.m., a 7.7 magnitude earthquake struck. Residents weren't hit by a typical rolling sway. They were jolted awake by a violent upward thrust that threw household objects, appliances, and furniture directly into the air, a physical effect survivors described as being on a trampoline. The localized ground movement immediately compromised major infrastructure. The maritime passenger terminal waiting room collapsed. Meanwhile, the roof of an assembly hall at the St. Peter Major Seminary caved in on students gathering for morning mass. Across the island, the earth literally tore itself apart. Highways buckled and split open, while intense landslides severed crucial routes between Ende and Nagakeo. The sheer intensity of this damage, concentrated so far from the deep-sea trenches where these quakes usually began, caught the attention of geologists. They were seeing signs of a tremor that was unusually sharp, vertical, and close to the surface. The human toll was heavy and immediate. At least 47 people lost casualties, many crushed by falling rubble as they slept. With over 150 homes flattened and local health facilities damaged, doctors were forced to treat dozens of injured patients in makeshift outdoor tents. Search and rescue teams from Basarnas, Indonesia's national disaster agency, began combing through the debris by hand, racing to find survivors trapped beneath the collapsed concrete. Adding to the chaos, coastal residents noticed the sea retreating early Saturday morning. Recognizing a classic warning sign of an approaching tsunami, thousands abandoned their ruined homes and frantically rushed for higher ground. This disaster presents a difficult question for responders. Flores is built to withstand the massive subduction tremors that typically arrive from the south, yet this specific rupture from the north tore through modern infrastructure with a violence that locals had never witnessed. To understand the destruction, we look at the macro-tectonic map. The Indonesian archipelago sits where the Indo-Australian plate crashes into the Eurasian plate, converging at 80 millimeters per year. The Sunda megathrust absorbs 70 millimeters, leaving a 10 millimeter gap completely unaccounted for. Those missing 10 millimeters are absorbed by a hidden fault system north of the volcanic island arc, the Flores back arc thrust. This fault is an anomaly. It accommodates leftover compression by pushing in the opposite direction, from the north. This opposing, highly concentrated pressure creates a continuously loading subterranean spring, coiled tightly right beneath the island's population centers. On the morning of August 15th, that spring finally snapped. Seismic data pinpointed the rupture directly on the Flores back arc thrust. What made this quake so dangerous was its depth. It snapped at a remarkably shallow 10 kilometers below the surface. This shallow rupture generated an extreme peak ground acceleration of 0.635 g, with concentrated energy radiating sharply upward. That intense upward acceleration is why residents felt like they were bouncing on a trampoline. The ground moved so fast and hard that it literally shook buildings apart and triggered the severe landslides now crippling rescue efforts. The destruction on the surface reflects the precise physics of the rupture beneath it. When a massive amount of tectonic energy is released so close to the surface, the structural limits of concrete and asphalt simply give way. For the people of Flores, this geological nightmare is tragically familiar. In 1992, this exact same back arc fault line ruptured with an identical magnitude of 7.7. That 1992 quake triggered a massive tsunami that swept the coast, claiming roughly 2,500 lives and leaving vast fields of scattered ruins behind. But the 2026 disaster played out differently. While authorities quickly issued a tsunami warning, the waves maxed out at about 1.6 meters. The coast was spared from total annihilation. Relief efforts mobilized rapidly to prevent further casualties. Indonesian military personnel and national agencies immediately began distributing thousands of aid boxes to displaced survivors. Improved early warning protocols and slightly different rupture dynamics kept the casualty rate down this time. Yet the underlying geological threat sitting offshore remains exactly the same, and the immediate crisis is far from over. The back arc thrust is still highly active, generating hundreds of aftershocks, some measuring up to magnitude 6.1, keeping survivors terrified to return indoors. The head of the National Disaster Management Agency, Suharyanto, emphasized that clearing blocked roads and securing trapped residents are the absolute first priorities. Delivering 50,000 aid packages to a fractured mountainous island is a logistical nightmare. Responders rely on helicopters to find routes through the severe landslides. The events in Flores revealed the broader complexity of the Pacific Ring of Fire. The deep subduction zones generate the region's largest events, but these hidden back-arc fractures bring that same seismic power directly into the heart of populated areas. True seismic survival in Indonesia requires understanding the complete tectonic picture and anticipating these